Question number 20. Prove that the following identities. First part, given root 1 plus sine A upon 1 minus sine A is equal to tan A plus secant A. First part, 1 plus sine A divided by 1 minus sine A is equal to tan A plus secant A. Left hand side is equal to 1 plus sine A upon 1 minus sine A. Rationalizing both sides by 1 plus sine A divided by 1 plus sine A, which implies under root of 1 plus sine A into 1 plus sine A, that is equal to 1 plus sine A raised to power 2, and denominator A minus B into A plus B, so A minus B into A plus B is equal to A square minus B square. 1 square is 1 minus B square is sine square A, which implies under root of 1 plus sine A raised to power 2 divided by 1 minus sine square A is equal to cos square A, and we can write it as root 1 plus sine A upon cos A raised to power 2. 1 plus sine A upon cos A whole raised to power 2. Root square is cancelled, and which implies we get 1 plus sine A upon cos A, which implies 1 upon cos A plus sine A upon cos A. 1 upon cos A equal to secant A plus sine A upon cos A is equal to tan A. So left hand side is equal to right hand side. Right hand side is tan A plus secant A. Solution, second part. Left hand side is equal to root 1 minus cos A upon 1 plus cos A. Rationalizing both sides, 1 minus cos A, 1 minus cos A, multiplying and divide, we get under root of 1 minus cos A raised to power 2 divided by A plus B into A minus B, that is equal to A square minus B square, which implies under root of 1 minus cos A square divided by 1 minus cos square A is equal to sine square A, that is equal to under root of 1 minus cos A upon sine A raised to power 2 whole power 2. Root square is cancelled, which implies we get 1 minus cos A upon sine A, which implies 1 upon sine A minus cos A upon sine A. 1 upon sine A is equal to cosecant A minus cos A upon sine A is equal to cot A. That is right hand side. So left hand side is equal to right hand side. Hence proved. Given first part is root 1 plus sine A upon 1 minus sine A is equal to tan A plus secant A. Taking left hand side and rationalizing both sides by opposite sign of 1 minus sine A, that is 1 plus sine A and divided by 1 plus sine A. The denominator will be A plus B into A minus B, that is A square minus B square, and numerator is A plus B into A plus B, that is A plus B raised to power 2. 1 plus sine A raised to power 2 divided by 1 minus sine square A. We know that 1 minus sine square A is equal to cos square A. 1 plus sine A upon cos A whole raised to power 2. We can write it as 1 plus sine A upon cos A raised to power 2 and root square is cancelled. So we get 1 plus sine A upon cos A, and we can write 1 upon cos A plus sine A upon cos A. 1 upon sine A is equal to secant A plus sine A upon cos A is equal to tan A. It's our right hand side. So left hand side equal to right hand side. And solution of second part, taking left hand side root 1 minus cos A upon 1 plus cos A, we are rationalizing both sides by opposite sign, that is 1 minus cos A and divided by 1 minus cos A. Numerator will be A minus B raised to power 2. And denominator is A plus B into A minus B, that is A square minus B square. A plus B into A minus B, that is equal to A square minus B square. A is 1, A square is 1 square, 1 minus B is cos A, then cos square A. 1 minus cos square A is equal to sin square A. Root 1 minus cos A upon sin A raised to power 2, root and square, this will be cancelled. So we get 1 minus cos A upon sin A, and we can write it as 1 upon sin A minus cos A upon sin A. 1 upon sin A will be cosecant A minus cos A upon sin A is equal to cot A. So we get cosecant A minus cot A, that is our right hand side. So left hand side equal to right hand side, hence proved. Thank you.